Good evening, everyone. Good evening. Okay, today I am going to discuss thermodynamic part 3. Today in detail we will study about law of thermodynamics. Okay. All of you, can you hear me properly? Yes, good evening. Shall we start the class? Yes, voice is clear. I am not using the headphone today. That's why I am asking whether the voice is clear or not. Okay. Only 1 hour I will take the class, because after 5:30 you are having as usual your regular classes, no? Like general classes, GK, psychology, everything. That's why 4 to 5 o'clock. Now 4, 5, no? Up to 5 o'clock I will take the class. Then later you can join your regular classes. Okay. Because I told continuously I can't take every day 3 hours. At least maximum 2 hours I can take. But 3 hours yesterday I felt fully tired. Even my voice also, it will become little strained, because continuously we have to talk in online classes, live classes, no? That's why. Okay. We will study in detail today the law of thermodynamics. Last class we studied about the properties of thermodynamics. This class we will study about in detail the law of thermodynamics. Very important one. One more class is I need to complete this thermodynamics. Then later we will discuss MCQ questions and also problems. Okay. Then what is the use of this law of thermodynamics? Thermodynamics law define the fundamental physical quantities like energy, temperature and entropy. It will give this law, it will give the relationship between the energy, temperature, entropy. Yesterday I explained what is mean by entropy. Entropy is nothing but the randomness or disorder. If you consider any object, how the particles they will be arranged, how randomly they will be arranged. It is nothing but entropy. Okay. Always you have to remember the new words, what is the meaning. Don't forget that one. Okay. Next one, that characterize thermodynamic system at thermal equilibrium. These thermodynamics law present how these quantities behave under various circumstances. Here this law, it will helps to study in detail energy, temperature and also entropy, and also how this physical quantities how they will be differ, then how they will behave in various circumstances, means various condition. What is the change it will occur in temperature, entropy, energy. We will study in detail based on the law of thermodynamics. Then here one more important word, thermal equilibrium. Thermal equilibrium means, assume you are having two bodies. One body is at the temperature of one system, otherwise body or system you consider anything. It will be, this one is 90 degree. Then this one may be, the temperature of this system may be 70 degree. Then heat, when you combine these two systems, heat it will transfer from higher temperature to lower temperature. Okay. Then the particles, otherwise the energy, it will transfer from system A to B until both the system they will acquire the same temperature. Maybe 70 they will get, maybe 60. When two bodies, when they will be in contact with each other, they have the variation in temperature. Then the energy it will transfer from higher temperature to lower temperature until it has to attain thermal equilibrium. Thermal equilibrium means both have to attain the same temperature. That's why remember the word. What is the meaning of thermal equilibrium? Means both the system they have to attain the same temperature. Thermal equilibrium means always you have to remember same temperature. That one only I explained here. What is the meaning of thermal equilibrium? Heat will flow till both bodies acquire the same temperature. This state, when there is no heat flow between the two bodies, when they acquire the same temperature, is known as thermal equilibrium. When two systems, when they will acquire the thermal equilibrium, then we will consider there is no transformation of heat. The heat, it will not get transferred because both they will attain the same temperature. No, when the temperature is the same, there is no flow of energy, there is no flow of heat. Okay, understood everyone? What is meant by thermal equilibrium? To attain the same temperature, the heat, it will flow from higher temperature to lower temperature. When it is attained a thermal equilibrium, then you can conclude there is no transformation of, otherwise there is no transfer of heat, it will takes place. Then here normally we are having 4 laws of thermodynamics: zeroth law, first law of thermodynamics, second law of thermodynamics, and also third law of thermodynamics. Let us study in detail what is the 4 laws they are telling. First one, zeroth law of thermodynamics. 1 minute, I will open the window. Because next to my home school is there. School they will leave at 3:30, but the students they will not go to home. In front of my apartment, everywhere they will stand, they will shout like anything. To avoid noise, I close the window. Now, after half an hour, after 40 minutes, now they are leaving the school. See, how the students, they don't want to go to home. Still you can listen the noise. Okay, but if I close the window, I am feeling like suffocation. We will not breathe properly if you closed everything, correct? No, ventilation is important. Next we will concentrate zeroth law of thermodynamics. Here this is the very important law. All the laws are very important. Then here the name is telling zeroth law of thermodynamics. Yes Rabia, good evening. Then here the zeroth law of thermodynamics states that if two bodies are individually in equilibrium with a separate third body, then the first two bodies also in thermal equilibrium with each other. Don't by heart this definition. In the simple word, I will explain here. Consider you are having the three system or three bodies. Then here, if you consider any two bodies, if they are in equilibrium, then third body also it will be equilibrium with remaining two bodies. Here I included one example. This means if the system A is in thermal equilibrium with C, this A is in thermal equilibrium with C, then the system B is also in thermal equilibrium with C, B also with thermal equilibrium with C, then you can conclude from this one AB also they will be in thermal equilibrium. Can you see if I use this pen? Understood? What is the zeroth law? What it is telling means, here if any two bodies, if they are in thermal equilibrium, if A is thermal equilibrium with C, then B is thermal equilibrium with C. C is the common here, but then C is common for A and B, no? Then A and B also they will be thermal equilibrium with each other. That third body also it will be thermal equilibrium with remaining two bodies they are telling. One more example I will give, then you will understand very easily. Consider two cups A and B with boiling water. When a thermometer is placed in cup A, it will warm up the water until it reaches 100 degree. Here consider two beaker or two cups, then take water, then in the cup or in the beaker you are consider the water, then here you have to boil the water up up to 100 degree. The temperature of that water, it has to reach boiling temperature. Then with a thermometer you can measure the temperature of the system A. I will consider this is system A. Then again in another beaker, consider the water. Again you heat this water. This also it will attain its boiling temperature 100. Then here this thermometer, it will show the temperature this 100 degree. Correct? Now when you dip in this system A, same thermometer if you dipped in system B, that also it will show the temperature 100 degree. Then this thermometer, this 100 degree, both all the three they will be in thermal equilibrium with each other. Correct? Now can we tell? Simple example. This one only we consider as a zeroth law of thermodynamics. Simple words, zeroth law of thermodynamics means if any two bodies, if they attain the thermal equilibrium, then third body also it will be in thermal equilibrium with remaining two bodies. That one you have to remember. Then one more daily example, zeroth law of thermodynamics. Hot coffee becomes cold after some time. Here consider in a hot coffee, then assume you forgot to drink the coffee, then after half an hour or after one hour if you come, then this hot coffee it will become cool. Then where this transformation, where this energy went, this energy it will be thermal equilibrium with outside environment. In the environment also you are having the temperature. In the outside maybe the temperature it will be less compared to this temperature of the hot coffee. Maybe hot coffee temperature may be 100 degree, you consider it is just beginning to boil 100 degree. Then outside maybe 30 to 35 degree. Then here the heat it will get transferred from hot coffee to the environment up to at which equilibrium it will get transfer. Both they have to attain the thermal equilibrium. Understood? Zeroth law, remember. The next one, the zeroth law of thermodynamics enable us to use temperature to compare the temperature of any two object that we like. Here we will use the thermometer to measure the temperature of a system or object. That is the zeroth law. Very important or easy also. That is. Next one, what is the first law of thermodynamics? This one we will consider even law of conservation of energy also. If you are feeling outside noise is more, you can tell me. I will close the window because today my husband took and went my headphone to the office. Okay, we are having only one headphone. I have to buy one more. Then I will not feel that difficulty. Okay, next one, first law of thermodynamics. The first law of thermodynamics also known as the law of conservation of energy. Always remember, the first law of thermodynamics is nothing but the law of conservation of energy. What is mean by this? You can't create the energy, you can't destroy the energy. Only you can transfer the energy from one form to another form. That one only here they are given. Status that energy can neither be created nor be destroyed, but it can be changed from one form to another form. That's why the first law of thermodynamics we can consider the law of conservation of energy also. Then here let us study few example here. First one, the flame is created using chemical energy and the energy from the fire is transferred to the marshmallow through heat energy. What is mean by marshmallow? Marshmallow is a type of confectionery that is typically made from sugar, water, gelatin, white to a solid but soft consistency. Means that is a type of food. See how you will cook the food. No need to remember this like a difficulty example. Here they included in the textbook, that's why I took the same one, but you have to compare with the transformation of energy. You can understand with easy example also. Don't get confused if I included the difficult example. Here this how you will cook the food. we will use the flame. In the flame, like what we are using in the daily life, using gas, we will cook the food. In the gas cylinder also, it is filled with chemicals, correct? No? Then that chemical energy, it will be converted into heat energy. Here they are included one type of food, marshmallow. How it will be? It will be that food is prepared with the help of sugar, water, gelatin. Any daily life food also you can remember here. Then next one, mechanical. The gas in the car in burned, generating chemical energy which is converted to mechanical energy. Whatever we are using in the daily life, we will use the car. Then in the car, we will use the gas. Even the car we can run with petrol, diesel, even I told no, gas also someone they will use. That gas it will burn. Then in the gas is a mixture of chemical energy. Then here the chemical energy is converted into a mechanical energy. These are the example of different types of energy. First law of thermodynamics, it will tell how the energy it will get transferred from one form to another form. One more example, when people eat food, chemical energy is converted into mechanical, heat and different chemical energies. We will eat the food regularly, correct? No? Every 3-4 hours we will eat food. We will drink coffee, tea, milk, some cold drinks, everything, because our body it has to get continuously energy. Then whatever we will eat, that we will give in the form of a chemical energy, that it will be converted into a mechanical, heat and different chemical energies. Then last one, a light bulb is powered by electrical energy which is converted to electromagnetic energy or light. With the bulb, what it will do? The bulb, it will convert electrical energy into electromagnetic energy or light. These are the few example of first law of thermodynamics. Then next I included two more example. The first law of thermodynamics may seem abstract, but we will get a clear idea if you look at few example of first law of thermodynamics. Let us consider few example here. Plants convert the radiant energy of sunlight to chemical energy through photosynthesis. Here you can observe how the plant they will prepare the food. You know, every plants they will prepare their own food with the help of the sunlight and also with the help of carbon dioxide. Yes, that process we will call it as a photosynthesis. In this you can observe the light energy it will be converted into chemical energy. We eat plants and convert chemical energy into kinetic energy. That plant we will eat, then that chemical energy it will be converted into kinetic energy. Means how we will use that one? We will walk, we will run, everything it will include in kinetic energy. And another kinetic energy example, we will swim, we will walk, we will breathe. Even I am sitting, even I am teaching you, I am also doing some work, no? Even I am wasting my energy. Don't think always we will walk, we will do some physical work only, we will losing the energy. No. When we will think also, we need energy. Without energy, can you think? Can you listen the class? No. Then switching on light may seem to produce energy, but it is electrical energy that is converted. Here, chemical energy is converted to kinetic energy. When you switch on the light, that electrical energy it will be converted into light or heat energy. These are the few example of first law of thermodynamics, how the energy it will get converted from one form to another form. Otherwise it will get transferred. Not converted, we can't convert, but we can transfer. Then we will study in detail the second law of thermodynamics. This today class is only theoretical part. I will explain all the laws. If you have any doubt, you can ask me. Still two more laws are there. Second, third, fourth. Okay. Second law of thermodynamics states that entropy in an isolated system is always increases. Already I told entropy is nothing but the disorder, otherwise how the atoms they will be arranged in a particular system. This second law of thermodynamics, what it is telling means entropy in an isolated system always increases. What is mean by isolated system? Yesterday I explained neither heat nor energy, heat, energy or mass, it will not at all enter into the system, it will not at all leave into the system. I given the thermoflask example, no, in the case of an isolated system, the energy and mass, it will neither enter into the system, it will not leave. But here the second law of thermodynamics, what it is telling, the entropy in an isolated system is always increases. What is mean by this? The randomness, otherwise the disorder. Randomness means if the particles, if they are arranged in a particular pattern, then that time we will consider the entropy, it will be less or it will be decreases. But if the atoms they are arranged irregularly and also they will be moving in zigzag motion, in that case we will consider entropy, it will be more. With example I will explain, don't worry. Then an isolated system spontaneous involved towards thermal equilibrium, the state of maximum entropy of the system. What is mean by spontaneously? Spontaneously means without time. If you observe any reaction, that one we will consider as spontaneously, without wasting time. Within a fraction of second you can consider. An isolated system spontaneously involved towards thermal equilibrium means, see, spontaneously means without wasting time in an isolated system, it will attain a thermal equilibrium. Listen here, an isolated system is a special type of closed system, does not even transfer energy across the boundary. Already I explained, even I included what is the meaning of isolated system. Then next one, the entropy of the universe only increases, never decreases. Many individuals take this statement lightly for granted, but it has an extensive impact and consequence. All this point is very important. The entropy of the universe is always increases, it will never decreases, because in the environment you can observe the randomness, otherwise you will not observe any pattern arrangement of, consider air only. Can you in the air, can you identify any molecules they will follow a particular pattern when they will move? No, they will not at all follow any pattern, they will be arranged randomly. That is the one of the best example. Okay, I will explain with example, then you can understand clearly. Consider putting an ice cube into a cup with water. Here consider ice cube, consider small ice cube. Then here consider one beaker, it contains water. Okay, this it contains water, normal water. Then inside the water put the ice cube. Okay, up to here the water is there. Inside the water put the ice cube. What will happen? Listen here. The water gives off heat to melt the ice cube. As a result, the entropy of the water decreases. The ice cubes absorb same amount of heat. Therefore, its entropy increases. The entropy increases of the ice cube is much greater than the entropy decreases of water. Therefore, there is a net increase in the entropy. Don't worry, I will explain. Then here the ice cube, consider the ice cube. In this ice cube, the entropy in the beginning, the entropy it will be very less. Why less? Ice cube is a solid, no? In the ice cube you can observe all the particles, they will be very close to each other. They will be like a fixed entropy, it will be less. But when you consider a liquid, when you consider a water, you can observe in water, you can see the gap between the particles. Then entropy it will be, I will consider more compared to the ice cube. Correct? No? Why the entropy of ice cube is less means the particles they are not at all moving, they will be fixed. When there is no movement of the particle, entropy it will be very less. But when you consider the liquid, the particles of liquid or water, they will be continuously moving. Entropy it will be more compared to the entropy of ice. When you mixed both, what will happen? This ice cube it will start melting. How it will start melting means it will gains the heat from the water. This ice cube it will gains the heat from water. Ice cube, what is the temperature of ice cube? You can consider 0 degree. Then what is the temperature of the normal water? Maybe consider 27 to 30 degree. Almost the temperature of the water it will be more, means the heat it will get transferred from water to ice cube, correct? No, then this ice cube it will absorb the energy, then it will start melting. When it will start melting, what will happen? This is the beginning case, what I explained, entropy it will be less. Once it absorb the heat, what it will happen? Entropy it will start rising, otherwise entropy it will be increases. I am talking here only about the ice. Then what will happen? This water it will gives the heat to the ice. Then here in case of a water, entropy it will be start decreasing. You have to remember why the entropy of water it will be decreases when you mixed ice with water, because this water it will gives energy to the ice cube. Then water it will lose the energy, no? Then normally when it's lose the energy before, the particle of water they will be randomly they will be moving. When they will lose energy, what will happen? They will move slowly, otherwise slowly they will move. It is nothing but entropy it will be decreases. But here what is very important means entropy increased in ice it will be very important. We will consider this, it will be more compared to here. I included the line. The entropy increases of the ice cube is much greater than the entropy decreases of the water, because which system it will gains the energy, that it will be more powerful, correct? No, here the ice it is absorbing the heat, then entropy of the ice it will be increases. That is very important here, because the ice it will started melting. You can observe, keep ice cube outside from the fridge, keep it on the table or somewhere, then after some time you can observe the ice it will start melting. Why it will start melting means it will absorb energy from the atmosphere. Atmosphere temperature is more, okay? Then once the ice cube once it will start absorbing the heat, the entropy it will be increases, then it will be start converting into a liquid. Understood everyone? Understood? If you have any doubt, I will explain this one. This is the best example of second law of thermodynamics. What is the second law statement? Once again I will read. What is the second law is telling? Entropy is in an isolated system is always increases. Like ice cube, always the entropy of an isolated system. Assume, why we will consider ice cube? Normally we will keep the ice cube inside the freezer, that it will be, when you kept inside the freezer, why we will consider that is an isolated system means in the freezer no energy it will enter into the freezer, no energy it will leave. The ice it will be, you can store that ice for a long time. That one we will consider as a best example of an isolated system. That's why entropy in an isolated system is always increases. Then any isolated system spontaneously involved towards thermal equilibrium. When see this ice cube up to, if you kept that one inside the water for a long time, then this ice cube fully it will be converted into a water. When this ice cube is fully converted into a water, that time we will consider that one it will attain a thermal equilibrium, because both the temperature of ice cube, almost all the ice is converted into water. Then that state we will consider both they will be in thermal equilibrium. Here this Spontaneously, why we will use the word? Because once both the system, when they will be in contact, immediately the changes, otherwise immediately you can observe there will be a rise in entropy. Understood everyone? If you are not able to follow, listen my video 1 or 2 times, then you can clearly you can understand. I think everyone you cleared about second law of thermodynamics. Can I move next one? Third law of thermodynamics. The third law of thermodynamics states that entropy of a perfect crystal at the temperature of Kelvin or absolute zero is 0. Don't worry, you will get the clear idea of a concept when we will solve multiple choice question. Okay. When we solve the question only, we will come to know whether we understood the concept or not. I am okay. Going to the next heat engine is there one more, that is also important. Better going to that heat engine, what I explained from yesterday to till today, I explained the properties of thermodynamics, then first heat and temperature, then this law of thermodynamics. Better tomorrow we will solve MCQ questions. Then you will, whatever you have the doubt, you will get the clear idea. Then after solving MCQ, I will go to the next heat engine. Okay. Today is not possible. I am not able to take the class because up to 9 o'clock you are having the regular classes. Tomorrow I will take. Tomorrow I am planning. I will take 2 to 3 hours maybe. Okay. Then next one. What is the third law of thermodynamics? This third law of thermodynamics states that entropy of a perfect crystal, here also entropy of a perfect crystal, it will be 0 when it will be 0, the temperature when it is 0. This temperature we will call it as absolute temperature. Here what they are telling, entropy, this entropy, it will be entropy of a perfect crystal. When it will be 0, practically this one is not it is not possible, but let us see. Entropy, at which case entropy it will be 0. Entropy of a perfect crystals, it will be 0 when temperature is 0 or absolute Kelvin or absolute 0. Again I am considering same ice example only, because water it will be at ice form at 0 degree temperature, correct now? Let us consider the steam as an example to understand the third law of thermodynamics. Step by step, the molecules within it move freely and have high entropy. Consider if the steam, it will be in the gaseous state. Gaseous state means you can see more gap between the particles. Particles, they can move very freely. Then in this case, the entropy it will be very high, because they will move with very high speed. If you decrease the temperature below 100 degree, the steam gets converted into a water, correct now? Once you started decreasing, if you steam, when you will get the steam, when you reached boiling temperature, or after boiling temperature, if you increase the temperature, then water it will start converting into a steam. Make reverse of that one. If you start decreasing the temperature, otherwise if you condense water, what will happen? The steam it will be started converting into a water, where the movement of molecules is restricted, decreasing entropy of water. This is the example of a steam. When you decrease the temperature, what will happen? This steam it start converting into a water. In the water, the particles they will be very near to each other compared to gas or steam. I am comparing with this gas, they will be close to each other. Then in this case, the entropy it will be decreases compared to this one. This E I will consider. Entropy it will be more in gaseous form. When it start converting into water, entropy it will be decreases, temperature also it will be decreases. That one only they are telling. When the movement of molecule is not completely, it will not restricted, they will be moving, but we will feel little restricted compared to the gas. Then here decreasing the entropy of a water. Then next one, when water is further cooled below 0 degree, again you decrease the temperature of the water up to 0 degree. What will happen? It get converted into a solid. It will be get converted into a solid ice cubes, correct no? Otherwise solid ice. In this state, the movement of molecules is further restricted, because all the molecules, they will be very close to each other in the solid, or in the case of an ice cube. Then there is no movement of molecules, almost it will, we will consider almost it will be 0. Then entropy of that system, it will be reduced more compared to this one. Here entropy is like fully reduced, almost this entropy we will consider as 0. As the temperature of ice further reduces, the movement of the molecule in them are restricted further. The entropy of the substance goes on decreasing when the ice is cooled to absolute 0. But okay, when you reach this temperature at 0 degree, then completely the ice cube, in the ice cube there is, you can observe there is no movement of the molecules. Then in that case, I don't know, entropy it will be 0, but practically it is not possible, because you can't restrict all the molecules. It is impossible. They will be, at least you can observe some movement, but here we will consider that is the best example, maybe absolute 0. Here only ideally the entropy should be 0, but in reality, here only I included in reality, it is impossible to cool any substance to 0 degree, because we can't achieve the entropy 0. That is impossible, but we can, at least we can assume when the temperature, when the entropy it will be 0, when there is no movement of particles. All the particles, they will be compact. Here in the case of an ice cube, all the particles, they will be compact. Only in that case we can assume, but here it is not sure whether the particles they will move or not. Okay, that's why even this I verified in the internet textbook also they are given to make the entropy 0. That is practical. In reality it is impossible. Okay, but we have to read, we don't have any option. Then one more important concept, this is very easy one, reversible and irreversible process. Already you know what is meant by reversible means, when the process when you can reverse, that is reversible. Irreversible means only the reaction it will takes place only in one direction. In reverse direction it is not possible. Easy. Okay, this I will explain within 5 or 10 minutes. Then later we can complete everything. We see so many changes happening around us every day, such as boiling of water, rusting of iron, melting of ice, burning of paper. These all are the example of an irreversible process, correct no? Boiling of water, it will be converted into steam. If it is occur in a closed surface, okay, then again you condense, you will get the water. In that case, it is also an example of reversible. Rusting of iron, almost it is like a irreversible process. Melting of ice, burning of paper, that also irreversible. All this process we observe that system is consideration goes from initial state to final state, where some amount of heat is absorbed from the surrounding, some amount of work is done by the system on the surrounding. Now for how many of such system can the system and surrounding be brought back to their initial state? Rusting, fermentation, we can say in most of the cases it is not possible. In this section we shall learn about the reversible and irreversible. This is only the introduction. Listen here what I given here, burning of paper, then rusting of iron, these are all example of an irreversible process. Because how the process it will happen, you can observe the change from initial state to final state. Then if any changes, how it will happen, here they are explained. Some amount of heat is absorbed from the surrounding. Even I told no, melting of ice, if you kept the ice outside, Why the ice, why it will start melting means it will absorb heat from the surrounding, and here you can tell in another word, some amount of work is done by the system on the surrounding. Okay, that is very good example. Let us consider this piston example. Here you can observe a compression. This also compress, this is expansion. These two are expansion. Here expansion. Here you can see compression. This is the initial position of the piston. This is the final position of the piston. Here you can observe, even though this piston 2 times it is get expanded, 2 times it is get compressed, but when you compare the final state and initial state, it will be look like same. Then this is also one of the best example of an reversible process, not irreversible, reversible. Then let us study in detail what is meant by a reversible process. A thermodynamic process, state I means state initial, state F means state final, is said to be reversible if the process can be turned back such that the system and the surrounding return to their original state. Okay, according to thermodynamically, if you want to give a definition what is meant by a reversible process means, see, if you observe same change in the initial and final, if you bring back the system and surrounding to the original state, then that type of process we will consider as a reversible process. Here no need to remember the definition, nothing, you have to understand the concept. With no other changes anywhere else in the universe, as we know, in reality no such process as reversible process can exist. The reversible process can easily defined as idealization model of real process, on which the limit of the system device are to be defined. They help in incurring the maximum efficiency of a system, can provide in ideal working condition, thus the target design. Okay, this one is not that much important. Here reversible process, according to thermodynamics, what you have to remember is, if you bring any system, if you observe initial changes, final changes, both also it will be same. So many changes like expansion, compression, everything happen also. If you able to bring back the system and surrounding to the same state and same position, that case we will consider that is a reversible process. Let us discuss with an example. Extension of spring. Yes, no, if you extend the spring, when you leave the spring, what will happen? It will come to its original place or original size. That is also best example of a reversible process. Then next one, slow adiabatic compression expansion. I showed piston diagram now. That is also compression expansion of gases. That is also an example of a reversible process. The next one, electrolysis with no resistance in the electrolyte. Consider the electrolysis of water only. Electrolysis means it will split into H plus and OH minus ion. Okay, even you can split this water into positive and negative ion. Even when H plus and OH minus, when it combine again, you can form water also. That's why this is also best example of an reversible process. The frictionless motion of solids. When there is no friction, the solids, it can come back to its original state. Then again, adiabatic or isothermal expansion compression, both also an example of a reversible process. Then consider what is meant by irreversible, in which the system and surrounding, according to thermodynamic definition, system and surrounding do not return to their original condition once the process is initiated. You can't bring back to the original state. Okay, once the reaction started, it will be, you can't bring to the original state. Taking an example of an automobile engine that has traveled a distance with the help of a fuel. then it will burn the fuel. Can we get back to the fuel? Best example, like vehicles, we will use car, bus, everything, we will use the fuels like petrol, diesel, everything. When petrol, diesel burns, then that vehicle, it will move. Can we get back to the petrol again? No. That is also an burning of petrol, diesel, burning of fuel. That is also best example of an irreversible process. During the process, the fuel burned to produce energy to the engine, converting itself into a smoke and heat energy. Yes, no? We cannot retrieve the energy lost by the fuel, cannot get back to the original form. There are many factors due to which the irreversibility of a process occurs. Okay, that one. One more example is there. Okay. What will happen in the case of that petrol and diesel? The friction that converts the energy of fuel to heat energy. When the car, when it will started moving, then you have the car tires also, no? Already I told when I am doing the friction lesson. Even tires, they will feel friction. Okay. Then you have to, against the friction, you have to push this car front. Then this fuel, it will burn, it will give the energy, then it will make the vehicles to move forward. That is one case how the energy we will use, friction that converts energy of the fuel to heat energy. The next one, unrestrained expansion of the fluid, which prevents from the regaining of the original form of the fuel. Heat transfer through a finite temperature, and reverse of which is not possible, as the forward process in this case is spontaneous. Spontaneous means within, there is no time gap within when you start the engine. Here why we included in detail here what is the process it will happen when you burn fuel, everything, because thermodynamics mainly in the next I will explain heat engine. Heat engine, everything we will discuss in detail, how the petrol, diesel engine, everything, how it will work in detail. That's why in thermodynamics we will study in detail how the engines they will work. Okay. Then mixing of two different substances which cannot be separated, as the process of intermixing of is again spontaneous in nature, the reverse of which is not feasible. It is not feasible means it is not possible. Here how the combustion of fuel, how the combustion of petrol, diesel, everything it will happen means, petrol, diesel is made up of chemicals. When you ignite, what will happen? They will start burning. When they will start burning, there is a some process it will happen. Okay, that process only we told, that process are spontaneous in nature, means within, there is no time. There is no waste of time, there is no time gap between the reaction. Then the fuel it will burn, then it will give the energy in the form of heat energy. Some amount of energy it will be used like a friction, everything. Okay, some processes are reversible while the some other are reversible in nature, depending upon their ability to return to their original state from their final state. In the universe also we can consider some processes are may be reversible, some process may be irreversible. Last example of an irreversible process, relative motion with friction. Yes, motion of any car, anything you consider. Then heat transfer. Once the heat it will get transfer, then again we can't regain. I am talking continuously from 1 hour. My energy is continuously wasting. Can I get back to the energy? That is an example of an irreversible process. Next one, diffusion. Yes, diffusion of different types of gases. Assume you are having oxygen, nitrogen, so many gases you are having in the air. Then all the gases they will get diffused. Can you separate oxygen, nitrogen, then carbon dioxide, all the gases? Can we separate? No. We can't. That is an irreversible process. Electricity flow through a resistance. Yes, once the electricity is flow, whether we will use or we will not use also, that it will get wasted. Can we get back to the electricity? No, it is not. It is impossible. This is this very basic concept like irreversible, irreversible. But in this class, what I explained like thermodynamics laws, first law, second law, third law, zeroth law, that laws you have to remember. Understood? If you have any doubt, you can ask me. After 2-3 minutes, I will close. Then tomorrow I don't worry, I will plan to solve this MCQ questions what I discussed from last 3 classes, from last 3 hours what I discussed we will do. Then tomorrow polynomial, I need 1 more hour, we will complete polynomial. Okay, ask me if you have any doubt. Maybe already you received the link, any link they given, any link they given for GK classes or psychology classes. Tell me if you have any doubt. No, you don't have any doubt in this class. What I explained, thermodynamics 4 laws. If you are not asking anything means any doubt means I will close the class. Okay, thanks for listening my class. At least thanks for you joined. Radhika, exact meaning of entropy means you have to remember the randomness, otherwise the movement of the molecules. There is no exact meaning of entropy. Maybe I included yesterday class, you check yesterday class, because normally I will not remember any definitions, because definitions if we started remembering we will forget the concept. Entropy means randomness, disorderness, otherwise how the molecules they will move in a system, that one you have to consider. Okay, thank you everyone. We will meet tomorrow. Tomorrow is Thursday, no? If tomorrow can I take the class from 4 o'clock? Tell me, tomorrow 4 o'clock, are you free? At least see the notification if any changes. If early classes also you are free, no everyone? If I take the class 4 also, it will be okay. I will discuss with ma'am. Can I take up to 4? Can I start 4:30? We will see. If I take at least 4 o'clock, then at least I can take 1 hour break. Then after 1 hour, if I take 1 hour break, at least 3 hours I can manage. Okay, thanks for listening my class. Okay, we will meet tomorrow. Okay, bye everyone. Take care. Read well. Concentrate. You don't lose your focus. Okay, start reading. Okay, bye.